Okay, now let's do a real life problem using the law of sines so we can find out what's going on. We have a situation here where we have a radar station number 1 and a radar station number 2, and they're both tracking a plane, and they're 35 miles apart from each other. Now, at this current time, point in time, or moment in time, radar station number 1 is saying that the plane is making a 37-degree angle with the side that goes to radar station number 2. So if I draw a line here, shoot and come off of that 37 degrees, we're looking at the plane. All right? But, okay, we'd like to know where that thing is. So in order to find out where that thing is, we're going to do a triangulation with the other radar station. Yes, we could do this and go ching-ching-ching and bounce that thing back and forth and do some time calculations to find out where it is. But it's a whole lot easier if we have another radar station and we can get an angle on that and we can actually triangulate it and find that thing. And if we have a third radar station that can do another one on it, and we can find that distance, we have more accuracy, fourth, fifth, so forth. The more stations, radar points we have, then the more accurate we have. That's just like GPS. The more satellites I'm receiving, the more accurate my location is. Why? Because they are all triangulating or calculating my location based upon their reference with each other. Okay? And as that reference, we get more reference points, we get a better calculation, exactly where that point is. So radar station number 2 is looking at that plane, and it says, wow, if I'm looking at you, radar station number 1, that plane is 54 degrees away from us. Okay? Obviously, it has to be at the same location. So, we're looking at a triangle where we know one side, we know 2 angles. Well, obviously, we can find the third angle, correct? That third angle has to be what? Well, 180. Angle of the plane, measure the angle of the plane, equals 180 minus 37 minus 54. I don't know what that is. Looks like it's somewhere in the neighborhood of 91. So I think this is what? 89 degrees. So this point right here is 89 degrees. So we know that. Okay? So we need to find, and we want to find how far away the plane is from number 1 radar station and how far away it is from the number 2 radar station. So we need to find A and we need to find B. So I'm going to use this form of the law of sines. So we come in with B divided by, across from it, sine of B equals P down here divided by sine of P. Well, what's B? We don't know, so we're going to have B divided by sine of 54 equals 35 miles divided by sine of 89. Come over here, this equals B equals, you don't need that, multiply this, we're going to have 35 sine of 54 divided by sine of 89. Okay? We do our little handy calculator, let's do that. Looking at 35 sine of 54, multiply those, divide by the sine of 89. I'm looking at that equals B equals 28.32 miles. So we're over here and this is 28.32 miles. Okay? So let's find the other one. That would be, we want this. So A divided by the sine of A equals, again, we're going to use P, divided by the sine of P All right? We don't know A, but we sure know what the angle A is. So A divided by sine 37 equals 35 divided by sine of 89. And again, multiply both sides by the sine of 37, we get 35 sine of 37 equals, or divided by the sine of 89. That right there should give us an answer. So let's see what we get. 35 times sine of 37 divided by the sine of 39, and I get 21.07 miles. Okay? So this right here equals 21.07 miles. Okay? So what we've done is we've used the law of sines to triangulate the location of that plane. Now, that's what the avionics of airplanes, jets, military aircraft, whatever, is made up of. Obviously, this is hard-coded into the integrated circuit, so it's just instantaneous. They sit there and they see the angle, paching, return an angle on a radar scope or screen, and it just automatically looks and says, oh, do I have another one of these? Yes, I do. Boom. Here is where it is. Shoot. Do I have a target? Yes, I have a target. Do you have another source for our location? Yes, I have another source. Can we get more accurate? Yes, I've got it. Toot, bang. I've got a solution. The solution is plotted. The pilot makes a decision on whether or not he takes care of that. How do we know where these planes are? They're looking at, okay, radar across the country or across the world. As they come into the different radar zones and the radar areas, they know what angles they are, and they keep track of those. They're constantly keeping track of where those are, what angles they have with the radar stations, and then they're triangulating those and seeing exactly where they are. Now obviously, the technique of radar is we can bounce that radar signal off of that plane and find out how long it takes to get to us. So we have a concept of where that plane is just from this, how far out it is. But it sure does help to get that second, third, or fourth radar return shadow on there so that we can figure those things out. Okay? That's what using the law of sines is about. Some of the things you can use it for, just one sample real life problem on law of sines.